Buckle up, cosmic explorers, as we rocket beyond Neptune's icy grasp and plunge into the frozen wonders of the Kuiper belt, the solar system's mysterious outer ring teeming with ancient secrets. Welcome to a thrilling voyage through this distant frontier, where we'll uncover the icy worlds, dwarf planets, and cosmic relics that hold the keys to our solar system's birth and evolution. What hidden treasures lurk in this chilly expanse? How has it shaped the comets that dazzle our skies? And could it conceal an undiscovered giant planet pulling the strings from the shadows? Get ready for an epic adventure brimming with stellar science, groundbreaking discoveries, and mind-bending mysteries that will keep you hooked from the first AU to the last. Let's journey to the Kuiper belt and explore beyond Neptune's orbit together. Imagine the solar system as a grand cosmic neighborhood, with the Sun as the bustling heart, the inner planets like Mercury, Venus, Earth, and Mars as the close-knit family nearby, and the gas giants Jupiter and Saturn as the powerful guardians further out. Beyond them lies Uranus and Neptune, the ice giants marking the edge of the known worlds. But venture even farther, past Neptune's orbit at about 30 astronomical units from the Sun, 1 AU being the average distance from Earth to the Sun, roughly 150 million kilometers, and you enter a realm of profound mystery, the Kuiper belt. This vast, donut-shaped region stretches from approximately 30 to 50 Australian dollars, a chilly expanse filled with billions of icy bodies, remnants from the solar system's formation 4.6 billion years ago. It's a frozen archive, preserving the raw materials of our cosmic origins in near-pristine condition, far from the sun's warming rays. Temperatures here plummet to around -230 degrees Celsius, cold enough to freeze gases like methane and nitrogen into solid ice. The Kuiper belt isn't just a barren wasteland, it's a dynamic frontier, source of spectacular comets and home to dwarf planets like Pluto, which challenge our definitions of what makes a world. As we delve deeper into this icy domain, you'll see how it holds clues to the solar system's chaotic youth, the migration of planets, and even the potential for hidden giants lurking in the shadows. Doesn't the thought of this distant, frozen ring spark your curiosity about what treasures it might hold? The Kuiper belt story begins with a prediction born from astronomical puzzles. In the 1940s, Irish astronomer Kenneth Edgeworth speculated about a reservoir of icy bodies beyond Neptune to explain the origin of short-period comets, those that return to the inner solar system every few decades or centuries. He reasoned that the solar nebula, the disk of gas and dust from which the planets formed, didn't abruptly end at Neptune but extended further, leaving behind small, icy planetesimals too sparse to coalesce into a full planet. Independently, in 1951, Dutch-American astronomer Gerard Kuiper proposed a similar disk, suggesting that Pluto, then considered the ninth planet, might be the largest member of this trans-Neptunian population. Kuiper's name stuck, though Edgeworth's contribution is often acknowledged with the term Edgeworth-Kuiper belt. For decades, this was theoretical, telescopes couldn't spot such dim, distant objects. The breakthrough came in 1992 when astronomers David Jewitt and Jane Lu discovered 1992 QB1, now called Albion, a 160-kilometer icy body orbiting at 44 Australian dollars. This confirmed the belt's existence, sparking a flood of discoveries. By 2025, over 3,000 Kuiper belt objects, or KBOs, have been catalogued, with estimates suggesting 100,000 larger than 100 kilometers and billions smaller. This discovery transformed our view of the solar system from a neat planetary disk to a sprawling, populated frontier. How did a theoretical idea become one of astronomy's greatest confirmations? Let's map the Kuiper belt structure, a complex tapestry of icy worlds. Spanning $20 wide, from Neptune's orbit at $30 to about $50, it's a flattened disk aligned with the ecliptic plane, though some objects have inclined or eccentric orbits. The belt divides into subpopulations, classical KBOs, like Albion, in stable, circular orbits between 40 and 48 Australian dollars, divided into cold, low inclination, and hot, higher inclination, groups, the cold ones pristine, the hot scattered by Neptune. Resonant KBOs, locked in orbital resonances with Neptune, like Pluto in a 3:2 resonance, 3 Neptune orbits for 2 of Pluto's, avoiding close encounters. Scattered disk objects, with eccentric orbits extending to 100 Australian dollars or more, like Eris, perturbed by Neptune. The belt's total mass is low, about 1/10 to 1/100 Earths, much less than predicted, suggesting depletion by collisions or ejections. Ices dominate, water, methane, nitrogen, with rocky cores and tholins, red organics from radiation. In 2025, Gaia's astrometry refines orbits, revealing dynamical families, groups from ancient collisions. This structure isn't frozen. Neptune's gravity sculpts gaps, like Kirkwood gaps in the asteroid belt. Isn't it fascinating how this distant ring echoes the inner system's dynamics? The Kuiper belt teems with notable worlds, dwarf planets that challenge planetary definitions. Pluto, discovered by Clyde Tombaugh in 1930, demoted in 2006 by the IAU for not clearing its orbit, is the belt's icon. New Horizons' 2015 flyby revealed a heart-shaped plain, Sputnik Planitia, filled with nitrogen ice, towering water ice mountains, and a thin atmosphere with haze layers. Pluto's 5 moons, including Charon, half Pluto's size, forming a binary, show chaotic spins from ancient impacts. Eris, discovered 2005 by Mike Brown, slightly smaller but denser than Pluto, sparked the dwarf planet debate. Its moon dysnomia hints at similar formation. Haumea, egg-shaped from rapid spin, has a ring and 2 moons, Hayaka and Namaka, possibly from a collision. Make, discovered 2005, features methane ice and a possible moon. Quawar, with ring and moon Waywat, defies ring formation models. Sedna, with 995-year orbit extending to 937 Australian dollars, hints at scattered origins or Planet Nine's influence. In 2025, JWST's spectra reveal surface chemistries, like hydrocarbons on Sedna. These worlds are time capsules, their surfaces etched with 4 billion years of history. What stories do they tell of the solar system's youth? The Kuiper belt's role as a comet source is crucial. Short-period comets, like Halley's, 76 years, originate here, perturbed by Neptune into Jupiter family comets with orbits under 20 years. Centaurs, like Chiron, are transitional objects migrating inward from the belt, becoming comets as they warm. Comets deliver volatiles, water, organics, to inner planets, possibly seeding Earth's oceans and life. The belt study informs this delivery, with compositions matching Earth's water isotopes in some models. In 2025, comet observations by SOHO and Parker Solar Probe trace belt origins. This connection links the distant belt to our world's habitability. How did this icy realm contribute to life's spark? Missions have revolutionized our knowledge. New Horizons, launched 2006, flew by Pluto in 2015, revealing geology like cryovolcanoes and chaotic terrains, then Arrokoth in 2019, a contact binary 36 kilometers long, pristine with methanol ices, showing gentle accretion. Lucy, launched 2021, targets Trojan asteroids but informs belt dynamics. Proposed interstellar probe, aiming beyond $1,000 could sample the belt. In 2025, New Horizons continues distant observations, imaging KBOs. These missions turn theory into vivid reality. What will the next probe reveal? Mysteries persist. Planet 9's hypothesis, from 2016 by Konstantin Batygin and Mike Brown, explains clustered orbits of extreme KBOs like Sedna, tilted, elongated, pointing away from the Sun. A 5 to 10 Earth mass planet at $400 to $800 could shepherd them. Searches with Subaru and Rubin Observatory continue, 2025 data may spot it. The belt's low mass puzzles, models predict more, perhaps collisions ground objects to dust, or migration depleted it. Interstellar visitors like Oumuamua, with odd acceleration from outgassing, suggest other systems' belts. Could the Oort cloud and Kuiper belt blend? These questions fuel research. The Kuiper belt's scientific importance is immense. As solar nebula remnants, KBOs preserve volatile compositions, unlike asteroids altered by heat. Their study reveals formation, gentle accretion in cold classics versus violent in hots. It informs exoplanet disks, like those imaged by ALMA around young stars. The belt's dynamics test migration models, explaining Neptune's orbit. Cometary insights trace water's delivery, tying to life's origins. In 2025, combined Gaia and JWST data refine this. What does the Kuiper belt mean for us? This icy frontier, a relic of birth, holds keys to our past and future. Comets from it shaped Earth, perhaps sparking life. From Edgeworth's prediction to New Horizons' views, curiosity unlocks it. We're explorers, charting the outer reaches. As we near the end, let's gaze ahead. The Kuiper belt, beyond Neptune's orbit, teems with ancient worlds and mysteries. New missions, telescopes, and dreams will illuminate it. What dwarfs await discovery? How will it reshape our story? The cosmos beckons, full of wonder. What questions stir your mind? Thank you for joining me on this epic dive into the Kuiper belt, beyond Neptune's orbit. I hope your curiosity blazes. If you loved this cosmic adventure, hit that like button, subscribe, and ring the bell for more journeys into the unknown. Drop your thoughts in the comments. What blows your mind about the Kuiper belt? What mystery should we explore next? Until then, keep looking up, keep wondering, and let's unravel the universe together. See you in the next video, Cosmic Adventurers.